All right, question number 1. It is asking us, first of all, it gave you the equation of a parabola. What form is this? This is called our factored form. From factored form, the reason I know it's factored form is because I see two sets of brackets and they're different. Vertex form looks like this. Y equals ax minus h squared plus k. And then standard form looks like this. Plus bx plus c. We've done a little bit of work with this. We've done some work with that. So now we're getting into our factored form. This is the third way you could have a quadratic relationship. And all of these different relationships give you different information about the graph. So factored form gives you the zeros. And the way we consider zero is what value would I have to put into this bracket to make it go to zero? Because this is a multiplication. It's -2 multiplied by whatever this number ends up being, multiplied by whatever this number ends up being. If I could make this number become zero, then -2 times 0 times whatever is going to go to 0. If I could make this bracket go to 0, then -2 times whatever times 0 is going to go to 0. So we have to think of what value would I have to put into x right now to make this bracket go to 0. What -3 gives us 0? It's 3. We always do the opposite. So see how it's a -3? We have x is 3. So 0 at, so the 3. So that would be one of the zeros. Math teachers argue whether you should use the words and or. At that point, I don't care. I just say and. I'm that bad teacher that when another teacher yells at you and you're like, yeah, but our other teacher, and they'll be like, no, and you can be like, yeah, that teacher actually said it. She's videotaping herself saying it. Okay, so with this one, what value could we put into the x to make this bracket go to 0? It's just going to be the opposite of whatever that is. So -1, 0. So that's the answer that they're looking for. You just rewrote the question. Determine the vertex of the function using the zeros. So the vertex of a parabola happens right in between the two zeros. What do I mean? Well, we're going to draw a really horrible graph. And you're going to humor me, and you're going to pretend that this is symmetric. Whoa. Okay, so if in a perfect world, this is a gorgeous, perfect parabola, the axis of symmetry happens right in between, worst graph ever, the two zeros. So if you can average the zeros, you could find the x value of the vertex. Whoa, I don't know why that happened. Okay, so I'm going to find the average of those. How do we take the average of something? You add two numbers together, or you add as many numbers as there are and divide however many numbers there are. So for us, we only have two zeros. So I always get the students to write this as the axis of symmetry because that's essentially what you're finding. X equals the two zeros, add them together. Well, one of the zeros was a 3. The other one was a -1. So I'll just throw that in a bracket just so you can see the why things happened. And then there are two numbers here, so I'm going to divide it by 2. So 3 plus a -1 gives us 2 divided by 2. That gives us 1. So what does this mean at, no, I reword that. Say the x value of vertex is 1. So right now, if we're, I need some more space. I didn't deal with that in a second. Let's unlock this. I thought that would be enough space. I was like, yeah, right, you're going to write this much. Oh, no. Okay, let's lock that. Let's lock this. Okay. I'm still on the video. I just picked it by, sorry. I wish I knew how to edit videos. Okay, sorry. Um, what was I doing? X value of the vertex is 1. So at this point, we sub x equals 1 into the equation because that's going to give us, if we look back up here, that's going to give us a y value. It'll solve for a y value. If we plug in the x of 1 into an equation, it'll give us a y. So we're going to go, I forgot it already, negative 2, x minus 3, x plus 1, y equals negative 2, x. It was minus 3, x plus 1 because it was a positive 3, negative 1. Okay. So wherever we see an x, I'm going to put in a positive 1. Negative 2, 1 minus 3, 1 plus 1. When you are plugging in the x value of your vertex, these two brackets will always have the same number, but it'll be opposite signs. So negative 2, positive 2. Whoopsies. Because it's exactly in the middle. So you're creating a mirror image on either side. Um, negative 4, positive 8. Therefore, vertex at an x value of 1 gives you a y value of 8. Last thing, not the last thing, determine the y-intercept. Y-intercept happens when x is 0. That's the rule. So our equation, which is negative 2, x minus 3, x plus 1, that equation, if we plug in an x value of 0, we're going to get what our y-intercept is. So this would be negative 2, negative 3, 1. And that gives us positive 6. Therefore, y-intercept at an x value of 0, a y value of 6. That gives us 1, 2, 3, 4, 5. That right there, 1 at 7, then it's going to be symmetric. Then I know I have a negative 1 and a positive 3. And you can graph it. And if you want to use Desmos, good, you can do that. Let's get full marks. Y equals negative 2, x minus 3, x plus 1.